All right, to find the area of this shaded region right here, we know that we integrate from a to b the top function minus the bottom function. Okay, so as shown in this integral right here. So what I'm going to show you how to do right now is to find the area of the shaded region if the top function changes somewhere along the region. So let's find the area of this shaded pink region right here. Well, as x goes from 0 to this intersection point, we see that cosine is the top function and sine is the bottom function. But as soon as we pass that intersection point, sine of x, okay, sorry, Vinny just interrupted. I'm not sure where I left off, so I'm going to start again. So to find the area of this pink shaded region, we know that as x goes from 0 to this point of intersection, the cosine of x is the top function, and the sine of x is the bottom function. But as soon as we pass that point, sine of x becomes the top function, and cosine of x becomes the bottom function. So we're going to need two separate integrals to find the area of this pink shaded region. To start off, we need to find this intersection point right here. So to find that intersection point, we set sine of x equal to cosine of x. We know that sine equals cosine when x is pi over 4, so this intersection point here has the x-coordinate of pi over 4. So then the area of the shaded region is the integral from 0 to pi over 4 of this top function, cosine of x, minus the bottom function here, which is sine of x, dx. And then we're going to add on the area of this region. So this starts at pi over 4, and this part of the region ends at pi. So we're going to integrate from pi over 4 to pi. And then the top function in this case is sine of x. The bottom function in this case is cosine of x. Okay, to evaluate, so we have to evaluate each of these integrals separately. So let's find an antiderivative of the first one. An antiderivative of cosine of x is sine of x. And an antiderivative of negative sine of x is cosine of x. And so that goes from 0 to pi over 4. Then we add on the value of this integral. An antiderivative of sine of x is negative cosine of x. And an antiderivative of cosine of x is sine of x. Okay, so now we just continue, plug in the limits of integration. So we have sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0. And now we have to add on this piece. So we get negative cosine of pi minus sine of pi minus negative cosine of pi over 4 minus sine of pi over 4. So we have sine of pi over 4, that's equal to root 2 over 2. Same with cosine of pi over 4. Then we have minus sine of 0, but sine of 0 is equal to 0. Then minus cosine of 0, which is 1, so minus 1. Then plus negative cosine of pi. Well, cosine of pi is negative 1, so we have negative 1, which is positive 1. Then plus sine of pi here is 0, so we have plus a negative 0, which is 0. Then finally, minus a minus cosine of pi over 4, so that's plus cosine of pi over 4, minus a minus sine of pi over 4 is plus sine of pi over 4, so we have plus another root 2 over 2. So in the end, we have root 2 over 2 plus root 2 over 2, these two cancel, and another root 2 over 2, and another root 2 over 2. So we have 4 root 2 over 2, which is equal to 2 root 2. So the area of the pink shaded region here is equal to 2 root 2. Okay, you can thank Vinny